Okay, so welcome to section 10.3, which is parabolas. And this is parabolas in a different manner than we've seen them before. So definition. So a parabola that's what we're defining, is the set of all points in the plane. The set of all points in the plane. Points in the plane. Equidistant. Equidistant from both a fixed point, which we call the focus. A fixed point. The focus, which is singular for foci. The focus. And a fixed line. And a fixed line, which we call the directrix, because it directs. Directrix. It directs the shape. Okay, so for IE or EG, I don't know which one I should use here, but let's say we have a parabola. Nope, it's not going to autocorrect. I would like it to autocorrect to a parabola. There we go, something like this. Okay. And what a parabola is, so let me make sure I have the same distance on either side. A parabola, like so, has a focus, which we can call F. Oops, why is that dashed? Focus, which we will call F, and then a directrix, which now I'll put this dashed, which is equidistant, meaning the same distance away. Let's call this capital D for directrix. It's a line. So the reason I'm not using lowercase d like I would for a normal line, you'll see in a moment, but, well, actually not momentarily, but eventually in the next section. Oh, shoot, come on. Okay. Okay, maybe that's a bit better. Okay, so if I take a random point on the parabola, the distance from that point to F and the distance from P to the directrix at a 90-degree angle is equal. Now note, okay, I'll call this Q. Now, of course, I didn't picture it perfectly, but it's supposed to be equal. So from the point to the focus is going to be equivalent to, from that same point to Q, where Q is on the directrix. Okay, and it's the closest point. So theorem. Let's do theorem in this one. Theorem. Okay, so a parabola with vertex, no longer center, it's vertex now, with the vertex h comma k, and focus and directrix, at a length, call it P, from the vertex. Are given by. And we have two possible orientations. Number one will be an up-down parabola, and that's going to be of the form x minus h quantity squared is equal to plus or minus 4p times the quantity y minus k. So that's up or down. And number two would be a right or left parabola. So right, left. So that's going to be y minus k quantity squared. Don't like that parenthetical. So y minus k quantity squared is equal to plus or minus 4p times the quantity x minus h. Okay, so let's see this in practice. So example. So let's plot the following parabolas. The following parabolas. As well as the foci, as well as the focus, rather. The focus and the directrix. And directrix. Okay, so number one, let's say we have x squared is equal to positive 4 times the quantity y plus 3. So I claim that this will be x minus 0 quantity squared is equals to 4 times 1 times the quantity y minus a negative 3. So I claim my vertex, wrong color, vertex is going to be at 0, comma negative 3. And I know that 4p, I'm going to do this in purple and this in pink. So I know that 4 times p is given as 4 times 1 in our case. So that means that p is equal to 1. And because this is positive, right, this is a positive 4, I know that, and it's x squared positive, means it opens upwards, right? This is what my parabola will look like. Okay, so 0, comma negative 3, x and y coordinate axes. X and y. Let's do 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, so my vertex is at 0, comma negative 3. I know my focus and my directrix are 1 away from the vertex. So here's my focus, 1 up, because it opens upwards. And my directrix will be 1 down from the vertex. So this is my directrix D. Okay, now let's say I wanted to figure out, well, actually I'm just going to go ahead and do this. Hopefully it'll auto-correct for me. And something, maybe not. Let's see. So I'll have my parabola. It's going to look something like, I don't know. Okay, where did that go? No, maybe a little bit farther up. Okay, something like so. And I'm going to note something. So let's note, what color should I use? Note. At y equals to, let's do -2, where the focus is down here. I'm trying to find the 2 points on the parabola. Well, that's y equals to -2. So let's plug that in. I would get x squared is equal to 4 times the quantity -2 plus 3. So I get that x squared is 4, which means that x is plus or minus 2. So this is -2, this is +2. So those are the 2 points on my parabola that align with the focus if I'm parallel to the directrix. Okay, let's do another one. So number 2, let's say we have quantity y minus 1 squared is equal to 8 times the quantity x plus 2. So this is now y minus 1. Quantity squared is equal to 8 is 4 times 2 times the quantity x minus a -2. So I know my vertex is at, remember, x coordinate first. So it's going to be -2, 1. I know that 4p is equal to 4 times 2, or 8, which means that p is equal to 2. So that's how far away the focus is from the vertex and the directrix. What else did I do? Okay, I know that this is a positive 8, so positive, and y squared means it's going to open to the right. Okay, so x and y coordinate axes. Pardon me, so sleepy. Okay. X and y. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay, so I know my vertex is at -2, 1. I know that I'm opening to the right, so my focus is going to be 2 to the right, and my directrix D will be 2 to the left. And I always open away from the directrix, meaning the line is like is going to, well, let's see. Let me stop talking. So, I don't know. Let's see. Will it autocorrect? Yes, it autocorrected. It's just my ability to draw it was bad. Okay. Okay, good enough for government work. Okay. So let's notice now that the focus is the y-axis, so that's x equals to 0. So what I'm going to do is note x equals to 0 implies that we get what? Y minus 1 quantity squared is equal to 8 times the quantity x plus 0. Or sorry, 0 plus 2. What am I saying? Oh my goodness. 0 plus 2. So that means that y minus 1 quantity squared is 16, or y minus 1 is plus or minus 4, which means that y is 1 plus or minus 4. So y is either 1 minus 4, which is -3, or 1 plus 4, which is 5. So my intercepts when x is 0 are at -3 and +5. Okay, it's good to have a couple more points on the graph. So let's do a couple more. So number 3, let's say we have quantity x plus 1 squared is equal to negative 8 times the quantity y minus 2. So rewriting this, we'll have x minus a negative 1 quantity squared is equal to negative 8 is really 4 times 2 times the quantity y minus 2. Okay, so I know my vertex will be at negative 1 comma positive 2. I know that 4 times p in this case is going to be 4 times 2. So that means that p is 2. And I know now that because it's negative and x squared, it's going to open downward because it's up or down. Okay, so let's see what we have here. Negative 1 comma 2, and it's opening downwards. Okay, so x and y coordinate axes. Okay, x and y. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3. Oops. 3, 4. 1, 2, 3, 4, 5. Okay, so negative 1 comma 2 is my vertex. I know I'm going to open down, so my focus will be 2 away from the vertex, going downward, and the directrix will be 2 away from the vertex going upwards. So here's my directrix. And I know that it's going to look something like, well, I tried something like this. See if I can make it a bit better. No, can I? No, maybe. Why is it not working? Oh, because this is farther down, that's why. I'm like, what's wrong here? Having troubles figuring it out. Okay. Oh boy, no, not okay. Come on. Okay. So let's look along the line through the focus, parallel to the directrix. What are these 2 points? Well, that's y equals to 0. So note, if we have y equals to 0, this gives us x plus 1 quantity squared is equal to negative 8, 0 minus 2. So we get x plus 1 quantity squared is positive 16. So x plus 1 is plus or minus 4, which means that x is negative 1 plus or minus 4. So that gives us an x value of either negative 5 or positive 3. So we had negative 5 here and positive 3. Okay, so let's do one more of these. Number 4. So let's say we have y squared is equal to minus 4 times the quantity x plus 3. So we have y minus 0 quantity squared is equal to a negative times 4 times 1 times the quantity x minus a negative 3. So I know my vertex is going to be at negative 3 comma 0 because x comma y. I know that 4p is going to be 4 times 1. So I know that p is 1. So that's a distance to the focus and the directrix. I know that this is negative. So that means since it's y squared, it's going to be to the left. Okay, so let's go ahead and plot x and y coordinate axes. Negative 3, 0. Okay, so I see where we are. X and y. Let's do 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2. So my vertex is at negative 3, 0. I know I'm opening to the left. I know my focus will be 1 away towards where the parabola opens, and my directrix will be in the opposite direction from whence I come. So what we get is something that looks like, let's see if I can do this. No, I can't. What is it? Never. I can try, but no. Almost. No. Okay. Good enough for government work. There is, as you can tell, there's something I actually am doing, and I will let you know what that is right now. So I'm not just willy-nilly plotting these, I'm plotting them very specifically. And how do I know how wide the parabola is? And that's what we're going to answer now. So definition. So the line through the focus. So the line through the focus. The focus. And parallel to D, the directrix. Intersects the graph of the parabola at a distance of, well, let's see. Let's look at this distance here. This distance here. Oops, no. Momentito. Let's do this distance here and this distance here. That's 4 on either side of the focus. Okay. Interesting. Now this distance here is also 4. This distance here is also 4 on either side of the vertex. But this distance here, this was 2. This was 2. So what's the difference? Well, the distance for this first guy was 2 and P was 1. Okay. The second distance here was 4 and P was 2. Once again, the distance here is 4 and P was 2. And I claim that the distance here is going to be 2 because P is 1. That is, what I'm saying is that it's going to intersect the parabola at a distance of twice P from the focus. Okay. So note, how do I want to say this? Should I say it in green? Yeah, let's say it in green. So note. I didn't even define anything, did I? Okay. Boy, I should not. And is termed. Let me see. What is this line? I didn't even. Wow, is termed the LATUS, latus rectum, which roughly translates as i.e. that is it est the correct side, because it's giving us which side the parabola is on. The correct side. Okay, so it's called the latus rectum. That's what the line is called. Wow, okay. Now that I've got that. So let's consider the following. If I have a parabola, let's create a focus here. And let's create a vertex here. The distance between them is 2, so I know that my directrix will be 2 away in the opposite direction, right? Because by definition, a parabola is equidistant from both the focus and the directrix. Well, that did not autocorrect to a parabola. Let's see. That did not either. Okay. Come on. Nope, not okay. Oh, okay. Could sneakily do it? Okay, so how do I know? I know that in line with the focus is going to be a line called the latus rectum. And for us, I claim that it's going to be, oh, come on. I'm trying. Why is it not working? It just really doesn't want to work for me. Almost? I think I got it. Okay. I almost have it. Not quite. But if we look at the line of the latus rectum, which goes through the focus, parallel to the directrix. So here's our latus rectum, meaning the correct side. I claim since the distance between the focus and the vertex was 2, that the distance between the focus and where the latus rectum intersects the parabola is 4. But that's not what I want to consider here. What I want to consider for this is something very interesting about some tangent lines. So what color should I use? Let's look at the tangent line to the graph of the parabola at the point. Okay, well, this is not a good tangent line because I didn't do a good graph. But if I had done a good graph, which is what I had hoped to do but completely failed at it, we would have had that both the tangent lines intersect at the directrix. Okay, come on, why is this not working? Okay, it does not want to work for me, but these guys, tangent lines, meaning touching in one point, to the parabola, at the intersections with the latus rectum, intersect on the directrix. If it were drawn correctly, you would be able to more clearly see that. So they're going to intersect both tangent lines on the directrix. Okay, which is kind of interesting. Okay, so let's do couple more examples in this section. So for example, so let's put the following equations into standard form. So put the following equations into the form involving P, and then plot using the latus rectum. So we're going to use the latus rectum in order to find the two other points that I was clumsily finding above. Okay, so number one. Let's say we have 3x squared minus 12x plus 12y plus 24 is equal to 0. So let's color code 3x squared minus 12x plus 12y plus 24 is equal to 0. Okay, so let's go ahead and factor the 3. So we have 3 times the quantity x squared minus 4x, is equal to, now let's subtract. I claim this is minus 12y minus 24. And while I'm here, I can take negative 4 divided by 2 and square the result. So what I'm going to do is I'm going to add 4 inside the parenthetical. So we have 3 times the quantity x squared minus 4x plus 4. But whatever I add, I have to subtract right out. So minus 3 times 4. And this will be equal to, on the right-hand side, well, not yet. Momentito. So we have minus, oops, wrong color. Should be purple. So we have minus 12y minus 24. Okay, so now we have 3 times the quantity x minus 2 squared is equal to, now what 3 times 4 is 12, so I claim we have minus 12y minus 24 plus 12 from here. So we have 3 times the quantity x minus 2 squared is equal to negative 12y minus 12. Now I can finally factor 12 from the two terms on the left, namely negative 12. What remains will be y plus 1. But I'm still not done. I need to divide through by the 3 we have here. So let's divide both sides by 3 so that it's in the form. So now we have quantity x minus 2 squared is equal to negative, well, 3 goes into 12 4 times, so 4 times 1 times y plus 1. Okay, finally, I can read what we have. The vertex, I claim, is going to be at positive 2 comma negative 1. I claim that 4p is 4 times 1, which means that p is 1. Okay, what else should I do? I know that it's negative. So since it's x squared, I claim that that's going to open downwards. Okay, so let's go ahead and plot this. X and y coordinate axes. X and y. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Okay. So 2 comma negative 1 is my vertex. I know my focus will be 1 away. And I know that there will be a line through that focus, the latus rectum. I know my directrix is also 1 away, but in the opposite direction. So the directrix is actually the x-axis in this case. Okay, so what 2 points do I have? Well, I know that P is 1, so I know that I'll be 2 away from the focus along the latus rectum. So we'll have something like so. Actually, I'll just try and make a nice one that will autocorrect. But I know how well that works. Okay. So now you understand I was trying to do this without the 3 dots already written because I hadn't taught it yet. But I knew where I wanted to go. So whether or not I could get there was the question. Okay, I think that looks kind of close enough, almost, maybe. Okay. So there we are. That is more of an exact graph because we have the latus rectum to give us the other 2 points on there. Okay, so let's do another one. So number 2. Let's say we have 2y squared plus 8y minus 16x plus 56 is equal to 0. So color coding, we have 2y squared plus 8y, then minus 16x plus 56 is equal to 0. So let's factor out a 2. From the purple, we'll have y squared plus 4y. Let's put all the blues on the other side. So we will have 16x minus 56. Now let's take half the linear coefficient in purple and square that so we get 4. So that's what I want to add inside the parentheticals. But whatever I add, I have to subtract back out. So I'm subtracting out 2 times 4. And we still have 16 minus 56 on, 16x minus 56 on the right. Okay, so now we have 2 times a quantity, y plus 2 squared minus 8 is equal to 16x minus 56. Let's add 8 to both sides. So we have 2 times the quantity, y plus 2 squared is equal to 16x minus, let's see, what is 56 minus 8 and negative. Okay, so that's going to be what, 48? Hopefully. I don't know. Math, not my strong suit. Okay, so we have 2 times the quantity, y plus 2 squared is equal to, let's factor the 16, and we will have x minus 3. Now divide both sides by 2, and we should be in standard form to read everything off the graph. So we have y plus 2 quantity squared is equal to 8 times the quantity x minus 3. So I claim the vertex will be what's with x, which is a positive 3, and what's with y, which is a negative 2. I claim that 4p is 8, which means that p is 2. Okay, I claim that this is positive, and it's y squared. So since it's positive and y squared, I claim that opens to the right. Okay, so let's go ahead and plot this. X and y coordinate axes. One, 2, 3, 4, 5, 6, 7. 1, 2, 1, 2, 3, 4, 5, 6. Okay, so my vertex is at 3, negative 2. I know my focus is 2 away to the right, and my directrix will be 2 away to the left. I know that the line parallel to the directrix through the focus, the latus rectum, is like so. Nope, no, it's not. It's straight, not like that. Okay. It's like so. Okay. I know that P is 2, so I claim that I'm going to intersect at a distance of 4 on either side of the focus. So it's going to look something like, kind of something like this. was number 2. Okay, let's do a couple more. So number 3, let's say we have x squared plus 2x minus 6y plus 13 is equal to 0. So let's color code. So let's say we have x squared plus 2x minus 6y plus 13 is equal to 0. So I claim x squared plus 2x is equal to 6y minus 13. So I'm going to take half the linear coefficient and square the result. Oops. So I get 1, so I'm going to add 1 on the left. So I'll have x squared plus 2x plus 1, and instead of subtracting out, I'll just go ahead and add 1 on the right, because whatever I do to one side of an equation, I can do to the other, and it's equivalent. So now on the left, I have, oh no, what's going on? I have x plus 1 quantity squared is equal to, so that's 6y minus 12. If I factor out a 6, it's going to be y minus 2. Okay, so I claim my vertex is going to be at negative 1 comma 2. But now I claim that for p is 6. So that means that p is going to be 6 over 4, which of course reduces. So 6 over 4 is going to reduce to 3 over 2. Okay, and this was it positive or it was negative? It was positive, and it's x squared, so I claim that this opens upwards. Yeah, well, I claim, whether or not I can draw it or not is another. Okay, so it opens upwards, and my vertex is at negative 1, positive 2. So x and y, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay, hopefully that's enough tick marks. See, negative 1, positive 2 is my vertex. It opens upwards, so I claim my focus will be 3 halves, which is 1.5, upwards. Now there's going to be a line through 3 halves there. 3 halves up, which is the latus rectum. There's going to be a line 3 halves down, which is the directrix. 3 halves is 1.5, so there we go. Okay, and I know that on the focus, I'm going to intersect, the parabola will intersect at twice 3 halves, or 3, so 1, 2, 3 away on either side of the focus. Okay, so let's go ahead and draw this. Yeah, well, let's try and draw this, shall we? And by we, I mean me. Okay. Oh, wow. Oh, my goodness. It almost looks okay. I'm just going to leave it. Just going to leave it because I've never gotten one that looks that good. Okay. So next one and final one, number 4. So we have y squared minus 2y minus 10x minus 29 is equal to 0. So let's do y squared minus 2y minus 10x minus 29 is equal to 0. So we'll have y squared minus 2y is equal to positive 10x plus 29. Now let's take half the linear coefficient in the quadratic and square the result. So we get 1. So I'll just add 1 to both sides. So y squared minus 2y plus 1 is equal to 10x plus 29 plus 1. So 10x plus 30. So on the left, we factor as y minus 1 quantity squared is equal to, factoring out of 10, so it'll be x plus 3. Okay, so my vertex, which is at x comma y, will be at -3, +1. I know that for p is now 10, so that means that p is going to be 10 divided by 4, which is 5/2. Okay, so 5/2. I know that this is positive, and it's y squared, so that means that it's opening to the right. Okay, so let's go ahead and do this. X and y coordinate axes. X and y. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4. So my vertex is at -3, 1. I know I'm opening to the right. So my p is 5/2, which is 2.5. So 1, 2.5. To the right is my focus. Actually, let me put the capital F a bit here. There's going to be a line through the focus parallel to the directrix. That's the latus rectum. Then we're going to have a line that is 5/2 to the left, so 2.5 to the left, and that is our directrix. Okay, now I know that the other 2 points are going to be at twice 5/2, or 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 on either side of the focus along the latus rectum. So this is going to look something like so. Okay, there's our parabola. Okay, I think this will be enough for this section, and I will see you in the next when we finally make all of this easier.